Oh, thank you, thank you. Yeah, and thank you for you and Alex for putting this together. I think it's a great forum for us to start a conversation with a broad, broad spectrum of different people involved in AI and machine learning space. So looking forward to all the questions and all the discussion and ideas that we're going to exchange here.
Great. Let's start with a question about some of the data science projects you've been part of. What's one that you found really exciting and interesting?
So, one of the most, more exciting projects being involved in has been one that, really opened my eyes to where and how data science can really make an impact, right? Like in a day-to-day news, you often hear about one of these big five technology companies and the breakthroughs they're making in the space and what are they using it for. And, a lot of it is really purely technology in the digital space, digital in, digital out. But in the industrial, in agricultural, in other more traditional or legacy industries, people don't think about the impact of AI as much. So previously, I was worked at a Fortune 50 agri giant, and they were very new to this space. Digitization was a goal for them, and part of that initiative was to incorporate machine learning into that initiative altogether. And what I saw there through one of the project is what kind of impact that AI can make in a physical space, right? So you take the data from the physical world and translate that into decisions that can be implemented in the physical world. So one of the projects that I undertook over there was applying machine learning in a way that can help farmers manage their crops. So you start to hear a lot more about this now, but like 2 years ago when we were first taking this on, the idea is still relatively immature because a lot of these sensors on the input side wasn't so much aggregated in the way to accommodate the traditional machine learning paradigm. And also, being in the physical world, and having to drive physical actions through your model is not a paradigm that is very common either. So it ended up having to build essentially like a tool that allowed to, using composite sensors, anything from moisture to pH, as well as using computer vision to gather all that data, feeding all those inputs through a model that we built to drive decisions to help farmers to, for example, like how to manage the nutrition in the soil, when and how to manage their crop during their entire growth cycle. And also the idea that another aspect of the project is really interesting, this idea how to implement your model into production. So most of the time, like I mentioned before, the model, like the data, lives in the virtual space, in the cloud. But now we're seeing more and more so is that there's more of a hybrid model. The idea that you can bring the data into cloud, train your model there, and then through a variety of different implementations, deploy your model into edge devices so that they're in the hands of people who doesn't need to link up to the cloud, who doesn't need Wi-Fi or cellular signal, that the model on mobile devices, on even IoT devices, on drones, on these remote robots, can make decisions based on those models in real time. And then whenever they do need to be updated, you can manage them like a small, swarm of devices, and then deploy updates and push new models and collect, kind of federated learning, anything like that in that sense. So yeah, so that project really kind of changed my perspective on what is possible. And I think after that perspective is really carried over when I joined Excella to really see in the government space, in the public space, as well as in different industries here based out of the DC area, a lot of more opportunities. I would say 90% of AI opportunity is still untapped, even given the current state technology, let alone what AI is yet to discover tomorrow.
There's a couple things in what you were talking about that I think are important that I want to highlight and give you a chance to respond to. One was the idea that using AI, so particularly in this example, to drive decisions. You talk about giving a farmer the information that she or he might need to determine when to take action on the crop, like when to harvest it, when to fertilize it, when to water it, things of that nature through, I assume, some kind of imagery or other sensory analysis, maybe the makeup of the soil or the moisture content there, what kinds of visible or invisible spectrum is being detected from the plants that are growing in the field, that sort of thing, right? So there's a lot of data out there. We have to figure out how to use that to help augment human decision making, right?
Absolutely, absolutely, absolutely. And I wish we had you on the project, Trent. You already pointed out so many of the important pieces of what that project, what made it so challenging. So, the farmers today, like a lot of the users in various industries, they're being challenged, and a lot of them are also excitedly embracing this technology revolution. They're no longer, the modern farmers, for example, are no longer rely on the old farmer's almanac by itself to really manage their entire season. They're not only are they sophisticated in terms of how do they trade and how do they deal with the futures and financial instruments, they also have to manage the cash flow, manage transportation logistics, manage, when and how much to fertilize, how much water, how to manage their entire crop, and when to rent or run their tractors, and all these variety of decisions individually could be driven or assisted by a model. But now what they're seeing, the farmers are starting to ask for this, is that is there anybody out there that can, a lot of these decisions are driven by some of the basic common data points, right? So for example, when do they plant weather-wise will often lead to when can they deliver on the other side of the growth cycle, and then how to time the market, how much to hedge, and then depends on the weather. That also drives up the insurance and logistic planning. So a lot of that, what they want is that they want a lot of business want. They want this maturity cycle in AI journeys, that they want to build a model to help them with the most difficult, complex decisions, but also having deployed these sensors and having growing sophistication and familiarity with how to use these apps, how to, having these edge models living on the edge. Eventually, they want to enter into an ecosystem where there's multiple models assisting them throughout the entire cycle, and then maybe holistically help them do better planning altogether. So I think that's one of the things that I also learned from that experience, is that, the adoption of AI, in a lot of ways, the journey is very similar across very different industries.
Mm. We've had some questions pre-submitted, so I'm going to turn to some of those now, but I also want to remind that all the attendees that you can submit questions while we're live here using the Q&A functionality that is present in Zoom. And one of these questions, I think, dovetails very nicely with what you were just saying, Henry, and it's how do we ask the right questions so that we can understand what a good problem would be to apply data science to, right? How do we know where and when data science ought to be applied? What are good candidates for that kind of work?
That's a great question. It's one that we often hear, right? How to find the best problem to solve? How do you do that detective work? So I think previously a lot of the automation that happens is more deterministic. What I mean by that is that there's almost always a clear decision tree, like a path you can follow. Decision points is yes or no, and then you make multiple choices, then you arrive at a range of fixed solutions or decisions you can make. Where AI and machine learning differs from that is the idea that you don't always end up with a clean decision. A lot of the way people think is that we ingest so much information, and when we make daily decisions, as small as when to have a cup of coffee, as big as, like what am I going to do to what financial planning should I do to plan for the retirement? A lot of these we can provide explanations, but we don't have those clear decision points where we say, if this is greater than that, then I should choose path A versus B. And that's where the AI power comes in. So if you do have identified a solution where, well, the complexity is not easily definable by deterministic logic, that could be a sign that AI is the right solution. Another area could be if you have a huge volume data, and then AI might enable you to do things that the manual process simply couldn't. One of the use cases we often see is really that maturation of NLP technology, natural language processing models, is that allow a lot of these public agencies to really dive into the documents and the unstructured data that had before that essentially is previously overlooked. Because if you hire a small army of people looking through these contracts, grants, processing papers and all this stuff, you still wouldn't able to get that holistic global insight about what is common across all documents, what is the latest trend emerging that is anomaly, right? You wouldn't be able to get that if you were processing all this on the individual level. So that could be another great sign that useful sign to identify AI opportunities. You have huge volume data, and then there is insight in there that is really not capable to be extracted by human efforts. And then thirdly, I would say is, this is more from the business perspective, is that especially earlier in the AI journey, if it is a first or second AI or machine learning project undertaken by an organization, they often want to have a very well-defined ROI on the other side of it. Because what you want is you want a use case to be able to quickly demonstrate real value in dollar terms, in cost saving terms, in revenue gain terms, in hours saved terms, so that you can use that essentially as a stake to mark the accomplishment of that initial step, which is often the hardest step to make. And then really borrow that experience to, kind of drive further down to find the next opportunity to really, become more sophisticated in how AI could be part of the overall technology solution.
Okay. So finding things that are a little bit more challenging than just a linear deterministic routine. We want to be able to apply some weight or decision-making or extrapolation to different alternatives. AI can help us with that. The second thing that you mentioned, I think, is quite interesting. The NLP, dealing with large quantities of data and trying to see patterns that would be very difficult for people to come up to speed on very quickly, just because there would be so much to consume. And the last piece, I would like you to expand on a little bit more, because basically you were saying, hey, organizations that get into this want to have a proof point. They want to have something that is valid. Does that mean it's important to clearly scope the business problem that they're trying to go after before they invest too much in AI and machine learning? Is that what the point you were trying to make?
I think yes, Trent. I think that's very often a big part of that. I can't remember which movie, but it was like a cheesy Revolutionary War movie. But there was like saying that a father is teaching his son how to shoot, and he says, "Aim small, miss small," meaning that if you aim for a very specific area, then when you do miss, you're still missing by a little bit. And I think a lot of times, kind of similar mentality should apply in choosing really any kind of new novel technology. A lot of times, especially if you get hyped up by what you hear in the general echo chamber of technology, how powerful AI is, and you're looking at the amount of value, tremendous amount of value these larger technology companies are driving in terms of revenue per employee because their productivity is magnified by all the AI they employ. It could be very tempting, especially given the sales pitches from all these solution companies, to say, well, let's just get in this. Let's make a big commitment mentally and financially. Let's dedicate it to a single tool. Let's try to deploy this thing across the entire organization, or dedicate this thing to be something that drives, count on it to really drive a big proportion of the growth in near terms. That should be the long-term goal. I'm not discounting that as a realistic goal, but I'm saying, like, for the first step though, there's a lot of lessons that can be learned by starting small, starting specific, with fast achievable goals, because a lot of the lessons learned is not so much of like, okay, how does machine learning actually work, but a lot of it is also like, how do you operationalize machine learning? How do you create a data community? How do you manage to do change management in an organization? How do you increase adoption of it? How do you get where is a proper place for machine learning to sit in your existing technology stack? A lot of these questions can be learned even with a small project. And all those valuable lessons learned could, very well influence your decisions in how and where and with whom to make the next step on. So I would strongly recommend, like this, the success of the long term for an organization in their experience with AI, given the long arc of history, so to speak, it will always get there. But I think the most successful and the least expensive way to get there is to, aim small, miss small. Failure will happen somewhere along that journey, but starting small and specific can really minimize that cost in terms of time and money.
All right. So not just have a strong sense of a well-scoped business problem, but also start small, as you say, and use that as a learning vehicle to discover what AI might be able to do for your organization and how it could solve some of the problems and challenges that you have. Will be learning that goes along with that effort.
Absolutely.
We had a number of students register, I know, and some of the questions that they were curious about were how to get started. So if you're relatively new to the field, haven't had much career experience yet, how would you recommend that people would pursue learning languages that are applicable in this space, pursuing internships, or getting started and crafting a career in this field?
Yeah, I think, that's something that I often reflect upon myself, because I feel like it doesn't matter how much experience you have in this space, given the velocity of the innovation, everybody is still a student. And to think back, if I were to start over again, in terms of technology stack, I think Python is still by far the most popular tool, because it is a general scripting language. It has capability to do functional, procedural, as well as object-oriented programming. So most of the open source tools and most open source tools do have compatibility with Python. And after that, I would probably say Java and R. Probably depends on if you want to do big data, big data focused machine learning, then Java. If you want to come from more the statistical side, for example, like a lot of data science, I know that happens. Now we're in election season, right? A lot of the polling, a lot of marketing. R could be a very good tool in that space. Scala, is kind of trying to do some of the things that Java does, but more specific to data science, a little bit better. And and honestly, in some ways, if you already have established experience in coding language, we have folks in Excella that has become machine learning thought leaders with .NET. JavaScript, TensorFlow has a JavaScript extension that does a lot of good, kind of a browser-based, client-side machine learning modeling. And also Go has really jumped up. If you've been monitoring this, I believe Go and TypeScript are two of the fastest languages growing in this country right now, actually globally. So they're not the bad place to, kind of get a sense of what some of these tools can do if you already are familiar with those languages. Now, in terms of where you're coming from, like how to learn, wow, that's a more open question. I would really consider, the person's background. If you're coming from like the analytical background, so to speak, if you have you have strong mathematics background, or in statistics, where you come from like a physical sciences, then I would strongly recommend spending more time learning about coding and learning about the tools out there, and really practice how to do things in the cloud, and try to kind of learn all the cloud tools. Now, a lot of people also now are coming into the data science space from the software engineering space, and if you're coming from that direction, like some of the folks are Excella, software engineers who are curious in honeycombing more into the data science space. My strong recommendation is the opposite, right? So it's like, kind of really understanding the statistical learning theories and why these things are supposed to work, what are some of the design assumptions, how to really deal with the data aspect of things. So that is because, coming from software engineering, there's a huge advantage of knowing how to, grab a package and use it and, kind of engineer the functions and, for example, tweak the code part of it. But most of the data in the real world is dirty, it's not clean, it's poor quality, and the distribution's off, and they don't really cooperate with a lot of assumptions. So unless you're a little bit strong with how understanding the underlying theories of all these different algorithms, you can plug and play and get something that is completely wrong. So yeah, so that's my general advice, but open to more follow-up questions that people might submit in the Q&A.
Great. And building off of that a little bit, and I think this might touch on the internship idea. Are there things in particular that you or others look for when we're hiring into the data science space at Excella? Are there particular skill sets or aptitudes? I mean, obviously there's a wide variety of experience in the kinds of people that we might interview or hire, but are there particular characteristics that someone should be trying to possess if they want to seek employment in this space?
I think that this space is now growing to a size that there's a lot of differentiation now, right? So I think back about all my peers and colleagues and coworkers who are still in this space. They're doing such different things, and they're utilizing, really what, kind of leaning on their advantage, what they're good at in the subfield or in a specific area. Some of them are really good about communicating ideas, so they do product management. They do, they become project owners for AI projects. And of course, there are machine learning engineers, mostly focused on how to optimize these, models as being built and operationalize them. And then there's like pure data scientists who are more of like about in the middle, like, looking at a data set, how to get from that to, wrangling, feature engineering, model building, and then, kind of outputting the model as deliverable. But then there's also different people in different space. I have a friend who is working like, for autonomous drone delivery, another person who is working for in the political science arena, dealing with like essentially, kind of a social targeting for political campaigns. So I would really say like a lot of it should be driven by the person's personal passion, like which area do they find passion to keep driving them. But also there might be new emerging areas. I think I remember very clearly like 2 years ago, Satella, like the CEO for Microsoft, Satya. Sorry, I'm like blanking his name right now. He famously said in talk that he sees that there's the machine learning, the data science area should be broadened to include other disciplines. So William's question in the Q&A saying like, what skills might be most needed in 2 to 5 years. A lot of the same skills that is really built the foundation for data science field will remain rock solid. Some of that will be automated away, just because that's what data science do, right? Like we just can't help to automate everything, including our own jobs. But what Satya like was what he was talking about is that think about AI ethics. Should we include philosophy majors, people especially in philosophy, to really into the data science field to collaborate? What about psychology? Now we are really making strides in natural language processing, but how do we inject personality? How do we inject kind of this idea of like, kind of how humans communicate versus how computers respond, right? How do we inject the humanistic component into that to make it smarter, more intelligent? So as we move forward, I believe that this field will continue to broaden and welcome people with different backgrounds. But I think the foundation doesn't matter where you come from. Certain level of technical understanding how algorithms work and how models are built and how the entire process work is still going to be a prerequisite.
You touched on it, but we had a question about non-technical skills, and I feel like that was a pretty good encapsulation of some of those things. But we hadn't talked about non-technical skills before you started answering. So I want to give you a chance to see if there's anything beyond I mean, one of the things that I got from your answer was it's a broad field, find something you're passionate about, pursue that. But are there particular non-technical skills that you think would be valuable for someone to have?
Yes, I think communication. I mean, not to say that it's impossible, but I think having the ability to communicate complex ideas to people who are not necessarily in the field is super important. Especially now, data scientists are working embedded into cross-disciplinary teams, right? You're working with DevOps engineers, Agilists, data engineers, software developers. Most of these people are not going to understand terms or concepts specific to data science. And a lot of data scientists, a lot of data science, concepts can be fairly abstract. Trying to explain to somebody, multidimensionality and what it means to, kind of reduce the dimensionality, what it means to, think about, the topology and a higher degree geometry and all these concepts. If you don't really kind of put yourself, with a sense of empathy and be able to communicate those ideas, to break it down progressively from simple to complex, to explain that in different levels, that makes the job a lot harder. And then, another skill I find really helpful is the willingness to collaborate. Kind of go seek out other people in different disciplines, because for machine learning to generate value, for it to be successful, for you to demonstrate your value as a practitioner, right? This thing has to become a product. It's become a part of something that gets into people's hands. And a lot of those things are already being, as very well learned areas by people who already built digital products, by marketers, by people who are knows how to design a technology roadmap. So it's important for data scientists to be open-minded, to really absorb all that information, and then try to, kind of interpret it in a way that makes sense for data science. And, data science is still new. It's still relatively new. Some of the areas, for example, ML ops is still maturing. And a lot of the idea that, is borrowed from the software engineering and from the, the more traditional data space. Most of it fits, some of them don't. But it is important for data scientists to really understand those concepts and then try to tailor it to the way that works for you, works for data science.
Great, thank you. That certainly reflects some of the experience that I've had. Like the most exciting projects that I've been on in a data science sphere, but also other technical domains, are those where you can get a cross-functional team together that collaborates really well. Right. So the multiple disciplines that are part of that group are sharing information and co-creating a new product or a new capability or some other new thing. And just the mix of getting all that knowledge together and the rapid, effective collaboration is what makes it really exciting. So I think my experience there resonates with yours. We have another question that could probably get kind of controversial. We're going to ask you to look into your crystal ball and theorize about what foundational skills might become automated in the next couple of years. What kinds of work or jobs? Let's kind of restrain it to the technology industry, the thing that we're more familiar with. What do you think where do you think automation is going to go, and what kind of a work is it going to take away?
In the broadest sense, in the last 10 years, what I learned is that all jobs will be automated away eventually. It's just more of the order of which. Let me kind of explain that a little bit. So before, right? So if you break labor into essentially 4 quadrants by 2 criteria, repetitive versus non-repetitive, creative versus non-creative, right? So a lot of times, we thought that machines in general, but also now augmented by machine learning, will go for the lowest hanging fruit, the non-repetitive, non-creative jobs. So that's the kind of jobs, and if you look at economic statistics, a lot of those jobs are taken by kind of automation, robotics, in manufacturing, and previously we thought, okay, well then service industry, right? Sometimes it's non-creative, but it's also non-repetitive, or are safe. But then we're now with the emergence of these more sophisticated neural networks and the ability to embed more computing than ever onto these devices on the edge, we're starting to see some of these non-repetitive, non-creative labors being replaced as well. So in the technology industry, we would like to think ourselves as more of the non-repetitive, creative industry. It's the idea that we are creating something new, we are coming up with ideas. Some of that will probably remain hard to automate, but at the same time, if you think about, for example, if you think about front-end development, uh, 15 years ago, if you build a website, you hire a web developer. But now everybody has a website because you have Squarespace, right? And then to take that example further is that with the last release of OpenAI's GPT-3, which is probably by some metrics the most sophisticated natural language processing neural network available. It's not publicly available, but Microsoft has an exclusive licensing agreement with it now. But there is a startup that also procured a beta test license and potentially will continue on development. Is that they build a demo that allow you to describe a web page, and then using that neural network to automatically write the JavaScript and HTML code to build that web page. So in that future, there's less creativity required, right? So a lot of times it's like Excel didn't eliminate accounting, but it eliminated a lot of accounting jobs. Squarespace has probably reduced the number of web developer jobs as well. That just basically, it's not to say eliminate the job altogether. Same thing with lawyers and doctors. There have already been more than 20 computer imaging, computer vision-based algorithms been patented and approved by FDA in the assistance of medical procedures and diagnostics. For example, like the newest, latest generation antibiotics was discovered using neural networks. So a lot of these non-repetitive creative professions are being challenged by AI as well. So I'm not gonna, like you said, it's like, I'm not gonna make any specific predictions about where the automation is happening, but I think a lot of assumptions about which jobs are safe is being challenged now.
Wow, that's quite fascinating, particularly the image recognition in the medical space. I think that's very, very interesting. You've mentioned ML ops a couple times now, and I know that this is a relatively new term, but I think it would be valuable if you could explain it. What is ML ops, and then talk about what makes it important. Why should people be thinking about it? Why should companies be concerned about it? What's the story?
So absolutely. So I think if a company already has a fairly mature technology ecosystem, and they have built their own web apps or mobile apps or whatever solutions they had built in house, they probably have to some extent already appreciate the value of DevOps. It's the idea: how do you do things quickly? How do you iterate on it safely and reliably? And how do you make sure that what you're building is secure, what you're building is going to be able to support, more users, or be able to migrate into a different cloud platform if that's what you want. Similar kind of logic, kind of applies to ML, like machine learning as well. Is that before, so much focus is about like hiring somebody who really understands, this hundreds of different algorithms, how to select the right one, how do you deal with the data to build the best performing model. But the best performing model is the one that actually is the one in production. You can have the most accurate model, right? For example, like the perfect example is like, I believe Kaggle, which is a machine learning competition platform. What really made it famous was Netflix famously years ago set $1 million prize to review or rewarded the team who built the best recommendation engine. They gave $1 million to the team that built the best model in terms of accuracy, but they never used that model because to operationalize a model was just unrealistic. It's too complex, unwieldy, expensive to run, all these things. So MLOps concept is like, well, how do you actually make your model real? How do you actually put it into production, expose it to users, make an impact on the business or on the mission of whatever organization that you're working for? And part of that is how do you create a system to, to do CI/CD, continuous integration, continuous delivery of your building model so that you can iterate quickly. Another piece of it is really the monitoring piece, right? So you have data drift, your model becomes less accurate. How do you respond to that? What is automation, to protect you from a model that might not be able to adjust to the fact that we have a pandemic now. And whatever data you have used to train your model likely hasn't dealt with a pandemic before. So with the proper ML ops can both allow you to notice the decreasing efficacy of your model, but also allow you to iterate and potentially produce a much better model faster in response. But of course, there are other kind of security issues with it, ethical issues that you can also incorporate into as part of your ML ops solution. So actually, Trent, if you don't mind, I actually want to take a little bit step back because I see Sienna has asked the question. I think I only answered kind of half of that question.
Oh, okay.
So yeah. So the second part of the question is, what advice do you have for junior applying to summer internship? So so I would say that it depends on really. It's hard to know your current technical level in terms of machine learning, but in my experiences, one is do your research about in terms of industry, which area interests you, what kind of data do you want to really dive into and you find interesting. That might help you guide you, searching a summer internship. But more importantly, I think is that not all data scientist roles are data science. For example, like different organizations title them differently. In Facebook, data scientists are people who write SQL queries. In Amazon, different titles have very different responsibility. Machine learning engineer, like I mentioned before, is tuning the models and operationalize them. People who really create new models based on their data is called research machine learning data scientists, I believe, or research scientist. And then data scientists are people who are potentially kind of more of essentially a little bit of consultancy for internal and also external customers. So make sure that you're applying to the role that has the responsibilities that can align to what you want to do. And then third part is that don't worry about I will focus, not to say don't worry about it, but I will place the internships. I will actually allow you to be hands-on over the brand name. So some of these bigger companies with the brand name, if you are entering, right, they might give you opportunities to look over somebody's shoulders to get an understanding how they do things. But if you were having the opportunity, for example, joining smaller startups to really kind of sit next to a data scientist and actually help out with the coding a little bit, tackle a little piece of the code, have a sense of accomplishment and own part of that product. If I were to have that, go over do it again, I'd probably choose a smaller organization, have a more intimate learning experience. But again, that's really kind of partly based on what you're trying to get out of it. Okay. Just want to make sure we cover all the bases and dot all the I's and cross all the T's here.
Well, thank you, Henry. Yeah. That was. I'm glad you had an opportunity to address that particular topic. I like that point. Go to a smaller organization where you can have a potentially broader impact or gain greater exposure to a larger subset of the work. Learn for yourself what you enjoy about it and where your skill set happens to be or where it gravitates to. I think that's excellent. It's got a parallel to what you were saying earlier about how when a firm is getting started with AI, they should start small and through that experience learn what its capabilities are, at least within its context. That's great. I wanted to, you addressed the MLOps question. You also said something about Agile and data. or agile approaches and how they can integrate with data science work, and that it's not always a good mesh. And I wanted to ask about that. Now we also have a question about that. The question is, what's the biggest mistake data science teams make when using Agile? And I think you could expand on that and say, what are some of the techniques from Agile that work for data science, and what are some that you've seen don't?
Oh, okay. Yeah, absolutely. That's a great question. And I think that is a question that, in my personal view, doesn't get enough discussion.
Hmm.
Partially because I feel like there hasn't been enough this cross collaboration between Agilists and data scientists. I wish there's more in industry. There's more discussion about people kind of pushing ideas. But in my experience, um, trying to squeeze data science into Agile and then just think that's the way it should be, that that kind of simplistic assumption might be dangerous. I think important thing is that to understand that there's very different development processes when it comes to data science compared to software engineering. Software engineering, a lot of times development is fairly linear and is additive. So you tend to have an idea, like, roughly the goals you want to achieve, whether it be a set of requirements or the goal to start collecting user feedback so that you can iterate upon those things. However, data science development, a lot of times it's not so linear. A lot of times it's like trial and error, and it's not so much additive. Sometimes it's even subtractive. So you approach a problem knowing that these are all the tools in my toolbox. These are all the algorithms. And then you look at the data, you look at the problems, like, okay, well, that's a supervised learning classification problem. All right, let me throw away all the tools I don't need for that. And then it's like, okay, my experience, given the sparsity, given the dimension of data, given the size of the data, some of the other tools become somewhat unavailable. But then given my experience, I'm going to try from top to bottom some of the algorithms I think is likely to work, right? So that's the subtractive process. And then a lot of times is that you might hit or miss, and then you find an algorithm that gets fairly good performance right away. But then to do that incremental improvement becomes very laborious, and sometimes it's hard to determine how long it would take. And some of that is, as I talk about it, is already pretty obvious, doesn't necessarily fit into agile process. But I think, I've been on teams that does Kanban, Scrum, or Scrumban, and the important thing is really introducing enough flexibility to accommodate that concept. Is that if you have trying to build an entire digital product, some of it pieces, software engineering, data engineering, DevOps, infrastructure, and all these pieces can follow the agile process. But you should also provide the flexibility to, whether to, how to correctly measure throughput in the common case, or how do you assign point system, even if the point leads to nothing, right? So, right, like if you spend time building a model and realize that model is not suited for this problem, that is still value because that didn't work, right? It's the process of elimination. You should still be pointed. So I think it's that whatever system can be adopted, where success comes in is introducing that flexibility to deal with the differences in data science development.
Yeah, there's an organizational learning paradigm that talks about the balance between exploration and exploitation. So exploration is gathering knowledge, learning, understanding about the domain of the problem space. And exploitation is then, we have arrived at a reasonable solution, let's execute against it. And I think, well, my experience has been that a lot of times agile teams with very brief time boxes, sprints, iterations, things like that, are more disposed to the exploitation element of that. We know what to do, let's get on with it. And data science seems to be more in the exploration space. As you were talking about, if we tried a model and we discovered it didn't work, that's valuable. We learned something and there's effort behind it. So, we should get credit for that, even though there's no delivery of working software to production. So it seems to me that the biggest mistake, or at least what you're saying, is the biggest mistake can be trying to fit the learning that goes on in data science in an agile box that perhaps isn't oriented as well to account for that. Would that be a good summary?
Yeah, thanks for, kind of expanding on that. I think that's a great way to explain it. And sometimes it's like, the reason I kind of been making distinction between data science and machine learning engineering specifically for that reason is that, it's like software engineering, machine learning engineering. The engineering piece is more like taking a known solution and, creating a creative application of it to solve the problem. But the data science piece is more the exploration part, like you put it so well. It's that idea that it's still really, it's not a hard science, but it's called a science in the sense that it follows a lot of the experimental procedures. A lot of times you are setting hypotheses, you are following the evidence and the data. And, the data in that case, a lot of times it's more like, the metrics against your model. And then you don't know necessarily that you will result in a solution. It is an exploration process.
Mm-hmm. We have another question, and I want to dovetail it with something that I've been thinking as well. The question builds on something that you've already talked about, and it's asking what kinds of data science skills are going to be most valuable in the next couple of years. And I'd like you to try to link that to where you think data science is heading. So what are the next most important or emergent trends, and what are the skills that would go along with that?
Sure. I would definitely want to be humble here and hedge my answer to say that this is very much from my perspective, and it's hard for me to be 100% or even 90% confident in this answer. But I think watching where the research is going, where these larger companies, unfortunately, this is one of those areas that is fairly unregulated, and outside of China, outside of China and parts of Europe, government involvement and investment is fairly limited. So a lot of the trends, what I'm seeing, is really driven by the private sector, where they're putting their money in terms of building labs and writing papers and talking about conferences. It's really, one is the research is trying to push for the next generation of algorithms, because that's really where the value really gains, right? We will have more powerful chips, cheaper storage, faster, 5G, so that you can have more powerful AI living in the cloud and runs for less money given the same algorithms. But of course, if you have better algorithms, everything is exponentially cheaper and more effective, right? So there's definitely the race to continue for the next algorithm. We are making marginal improvements in the last few years. I haven't seen anything groundbreakingly provocative, but there's a few ideas out there like capsule networks and things like that potentially could be a game changer. Of course, anytime we're starting to see some kind of talk about, starting to experiment with quantum computing and combination and combine it with neural networks, what kind of computation and kind of coding that will go with it. Now, in a more immediate sense, right? Like I mentioned before, like even given the current state of technology, there's so many problems that hasn't been solved, and we're collecting more and more data. So a lot of problems that we are experiencing today can already be solved. So what skills might be more valuable in that sense is one is this hybrid idea, the idea that how to build machine learning models in more efficient way, smaller models, fewer computations per model, and so on, to be embedded in smaller and smaller devices. 2 years ago, Google came out with a proof of concept as a simple, very simple signal detection model that can essentially detect audio and is less than 1 kilobyte. And they were able to run it on a strip that is powered by body heat. So, that is really something that I feel like is part of the future. It's the idea that model can live everywhere, and we are, having the sensors and everything, drones and everything is really, everything behind it is really the cell phone. The cell phone is really the driving force behind all these different components that has been put into smart cameras, put into drones, put into these robots. And having that proliferation and that kind of models everywhere in varying sizes and very dealing with specific problems is going to be part of it. And managing those thousands of models, of course, is the second area is ML ops. You can automate a lot of these building of the models through essentially just throwing everything, every single model, and just saying, I'm going to just run the most powerful server for 3 days, and then just like check every single model and see which one performs best. And I'll just do it again and try to tune the parameters blindly and see what turns out. But at the end of it, you still need good ML ops to manage all the models being produced and runs in production. And, it's just like trying to manage a gigantic code base, right? And another area is really the idea that how do you interpret the models? So this is where the regulation piece comes in. You can ideally, hopefully, we'll come at this as from the AI ethics angle, how to practice machine learning in an ethical way. To not create models that has inherent biases, to really test the models so that it doesn't have negative social impact or burden impact on the user base that it's supposed to serve. We don't really have that legal obligation or even that social obligation, from the demand side in this country, but in Europe and even in China, believe it or not, there's already legal framework guaranteeing consumers and end users certain rights in terms of how the models affect them. They can actually request, for example, the model to not really be applied to them, or to actually demand an explanation how the model made the decision. If similar framework is being, legal framework becomes adopted in the US, every single model out there is going to need to explain explainability mechanism behind it. Part of that is going to be something you need to build into ML ops pipeline. But the other part of it is really the consideration as a data scientist. When you build a model, do you understand how to make it transparent? If you build a neural network and you make a prediction, do you understand how to take that neural network apart to really understand the interaction between the nodes and how each layer is really compounding, essentially certain features in your inputs to arrive at that output? And how do you explain that to somebody who is, who is really an end user and may not really understand, all the terminologies in neural networks? So I think that's an area that is very new, and we don't really have a holistic answer for it. But I don't think there's a way for us as a society to really sidestep that. I think we will need that, and hopefully we'll have that started soon, because if we let AI get so far ahead of us before regulation catches up, it's going to be a lot harder to rein it back in. To shut down, for example, New York City did an audit 2 years ago. They realized they had very little transparency into all the models, they call it automated decision makers, how they make decisions. But do you shut it down? Because those models determine where street cleaners go every week, or which kid goes to which public school. So if you shut it down, then how do you, kind of go back to the way? How do you make those decisions? But then, of course, it's only fair to be able to, for somebody to ask questions, why did my kid get assigned to a school that is so much further away than the one from, have one just down the block? New York City may need to explain that, but they really currently don't have a way to do that right now.
Yeah, well, Henry, I heard 4 things, and we're just about out of time, so I want to try to summarize quickly and then close things out. What you mentioned, or at least what I took from what you mentioned, are the next generation of algorithms. So get good at writing the next generation of algorithms. That's a good skill to have. Work in the distributed or hybrid space, right? So extend the algorithm out to the edge, so it's not just contained on a large computing system somewhere. ML ops, which integrates with the above, right? Integrates with the extension. And I think there are lots of pieces there that we could talk about more in terms of how to make sure that the algorithms that are in use are adapting and adjusting based on the data changes in the world around them. And then ethics and explainable AI, being able to explain to people who are impacted by the decisions that algorithms are making or the decisions that they're recommending, why those decisions are being made, and why it is to the benefit of the whole or them as individuals. And if not, then what do we do about it? Is that a good summary?
Absolutely. Great summary.
Oh,
I should
good.
have given that answer. It would have saved everybody a little bit of time.
That's okay. Well, good. I want to thank everyone who's joined us. I can see some people are starting to drop off. We are at the top of the hour, so we're out of time. But thank you to all who have attended. We'll be doing the next one of these in about a month, and we'll be talking about .NET and all the exciting things going on in .NET, probably also getting into some of the machine learning capabilities that it offers. So thank you very much, Henry, for being part of this, and for all of you who attended, and Alex as well for helping keep us on track and running the slides. We'll see you all later.
Bye, everybody. Thanks for attending.